As many of you have known, especially if you saw the articles that came out yesterday, the world now has an 8-story, a 9-story, a 10-story buildings made with wood. And they're not just in one place, they're all over the place. They're in Austria, they're in UK, they're in Australia, and hopefully very soon also here in BC. It gives me great pleasure to introduce Mr. Hubert Rhomberg. He's the CEO of Rhomberg Holdings in Germany and CREE in Austria, CREE company there. And I think they've now called themselves CREE Buildings, Inc. in the US, based in Berkeley. He's active in the fields of construction, railway technology, and resources. He holds a Master's of Science degree from the Technical University in Vienna, Austria, and a degree in business administration from the University of St. Gallen in Switzerland. So without further ado, I would like to introduce Hubert.
Thank you. Thanks a lot for the invitation. Last time was here, Vancouver, 26 years ago, so something changed. We heard today about buildings 8, 9 stories out of wood. I want to show you 30 stories out of wood today. I had the first presentation this morning, and after this presentation I decided to make another presentation, a different presentation in the afternoon, because I wanted to go in some technical details. Probably they're interesting because we have a lot of specialists here, and it's not often that I can speak to people who are so open to what I'm talking about, because usually I'm a member of the construction industry, the very old construction industry, and we came from concrete. So my competitors, they don't like me that much anymore, because I'm always talking about wood and the chances of wood. But it's very important to know how come that a company like we are, a classic construction company, general contractor, developer, ends up with wood, and not a wood company starts like building big, high wooden buildings. That's the story is quite probably interesting how we got there. So the name of our construction company is Rhomberg. What you see here is CREE. That's a small startup company we just started 3 years ago, after we thought we proved it on paper, and now we have to do it. Not just make research and try things on the papers, or really do it. And then we founded this company, and this is at the moment the only company where I, as the CEO of the holding, is still managing, because my heart is in there. Because sustainability is such a great word, raped 1,000 times by everybody. So I feel a tendency right now that greenwashing is getting stronger. Everybody is getting some kind of certificate, making a concrete bunker and putting some stuff on it and then make it green. So I think sustainability is going on in a company and through a company if it's from top down, the issue. And that's why a lot of medium-sized, family-based companies are moving forward faster than other companies. Because if you're a CEO of a company and you have a 3-year contract, you will not start doing things which will probably turn to be successful in 5 years or 10 years. So this is a big problem. And on the other hand, the way we think, if we really want to be sustainable, is not the way you can be successful as a manager today in the business we have. So I have the luck that I'm now the 4th generation in a construction company. That's why I got this job just by, inheriting it a little bit. Yeah, that's not easy, because everybody knows that. Everybody's looking, what is this guy doing now? What is his approach? So when I took the company over 13 years ago, I thought I have to make a new strategy for the whole company. And then I realized first I need a strategy for my life, because you should know what you want to do with your life and then think about what you do with your profession, because that should fit. And now I'm glad that it fits today. And at that moment, I realized that we cannot proceed the way we proceed. I read a lot of stuff. I read these figures. If we keep on doing what we're doing and the way we're doing, we need 2 planets in 30 years. Some say 2.5 planets, the others 1.5. I mean, it doesn't matter. We just have 1. So that sounds easy. Okay, let's do something. So, but what can we do? We think this planet, I always say it's a service machine. It delivers services for mankind. One service is clean air, liquid drinking water. The other is pollination of blossoms. Most of the people don't know. No bees and insects. 5 years later, 2/3 of the mankind is dead because no food. So these are just the simple things which are donated or generated as services from the planet, and it's just not a part of our market economy. So that's a problem. And so I said to myself, what can I do with my business? How can I make a change? Because usually everybody says, okay, these guys should go ahead, you know. And so if you are building, constructing, your products live probably 50, 100, 200 years. So you should think about what the product should probably be in 50 years, and it's still the product you build now. So I asked myself how we will live tomorrow. And today, over 50% of world population live in cities with more than 1 million residents, and still growing. And it's a good thing, because most of the people don't know that the inhabitant of a city is more sustainable than a person living in a rural area. That's because transportation, infrastructure, all that stuff. So, but that's the way it goes. So if we want to deliver new solutions for the world, we have to look at the cities. We have to have solutions in the cities, and that's very important. You will see after, because we ended up with skyscrapers out of wood, and everybody asks us why skyscrapers of wood. I said, because we have to go to the cities, we have to go up. Wood, because it's a resource issue, we'll hear after, and a systematic approach. So that's why it's important. Cities are growing. 75% will live in mega cities in 2050. And 50% of the world's energy consumption is used by cities, by the buildings. So how can we satisfy that? This is an unsustainable way. It's a car-based society. And that's not the way we can grow the cities. That's not the way either, because this is 100 meters high. It's in Dubai, but it's definitely not sustainable, this building. So there is a limit in height concerning sustainability, because from a special height on, you need way too much energy to bring up and down people and stuff. So that's not the solution. And the other is, how do we use the resources of our planet? Today, 60 billion tons of resources are extracted from the planet, moved, converted, whatever, with a lot of waste. And that's double what the Earth itself does, with volcanoes and stuff. So that's quite a lot. I mean, in Canada, probably you think, hey, I mean, we have such a big country, we have so many resources, we don't have that many people looking on the side of the land, but looking on the whole planet, it's a really big issue. It's not, we will not be able to sustain our lifestyle without change, and that's why the resources is a big issue, and it's a peace issue too. The military has There are some studies where the military sees the biggest problem in the future for wars in the fight for resources. I mean, we have the oil, we have the rare metals. There will be big problems coming out of this if we don't find solutions. So the resource scarcity is a big issue, and 40% is used by construction industry. No industry uses more of the resources on this planet. So that's when I said to myself, so if we don't make a difference, who else should? And the same is with the CO2 emissions and the transport. 60% of all transport on ton kilometers on the streets is done by the construction industry. So we have to find ways to reduce the resource consumption. So this is a silly question. I still have it always on the agenda. How heavy is 1 kilogram of copper? And a kilogram of copper has 350 kilograms of resources. To make 1 kilogram of copper, you need to extract it, you need to transport it, you have the waste, you have the water, so it's 350, the factor. It's huge. That's why we're hunting for bad material in our buildings. So just look, what do we want in the building and what do we don't want in the building? But therefore, we should know what's in the building. And most of the people, they don't even know because we're just prototyping. And why is that? Because there's the ecological backpack. Bio Schmidt-Blake, he's now a friend of mine. He changed my mind. He was the guy who showed me all this and said, Hubert, if you want to make a difference, think about this. And he really calculated it for all the materials. So steel, for instance, is factor 8. It's quite good because 80% of the steel is recycled. So it's a better factor. Aluminium has 28. So if you use 1 kilo of aluminium, you really use 28 kilograms of nature. And a lot of energy coming with the material. A big thing is, we now in Austria have such strict building codes and laws that we have very, very low energy consumption already. So low that I sometimes say, why putting smart metering and all even more stuff and technology which is consumed resources before just to measure that little? But most important is the material, the construction material you bring in the building has used energy to produce it. So we have to look at the whole life cycle of this building. That's what in Germany starts right now. They say we evaluate the building from the whole life cycle because they want to change their energy system from nuclear to renewable in Germany. So they have to save energy too, and not just in the building, but in the parts going in the building which are produced. This is very, very important. So that's what I said. It's 350 with the copper and 8 kilograms with steel. So just imagine that's the real weight. Imagine walking with a jean 32 kilograms or a mobile device, smartphone with half a ton and the desktop computer for 1.5 tons. The gold ring, you know, that's a special issue. So there's a word going through construction industry and all industries is urban mining. It's the most scientists guess that the resources we still have on the planet, half of that which is left is already in the industrial countries. In cars, machines, buildings. So the way we can sustain or we can proceed with our economy, like in Austria or Germany, we don't have our own resources, is to get it back. That's why it's called urban mining, to get the stuff back, which we built decades ago. So the way we build today, it's a hard issue. Everybody knows there will be a scarcity in resources. In 80 years, 100 years, our grandchildren will say, hey, at 2012, you know exactly what's going to happen with the resource scarcity, and you designed and built the same way. We cannot get the stuff back out. With the system we developed, our approach is to know exactly how much material is in it, where is it, and how to get it out. And in the morning, I already said it. Once we said to a client, I give you 1% more rebate on the building if the material belongs to me and you call me in 100 years or somebody else, and I can take it. You know, nobody does that. But something happens in the mind, because in that moment, the guy says, oh, careful, probably it's a bad business for me. I have to, you know, I have to check this. Probably it's much worth then, and it is, but not for him. Probably for his company, for his children, grandchildren. So that's a very big issue. It's lacking responsibility, building prototype, designing prototype buildings, gluing stuff together, which you can take apart and get back in the future. That was one big approach when we said it has to be a systemic, prefabricated building you can get back. So urban mining here is we know the material, we know how they have been used, and we know how we get it back. So this is a construction site. I can say that because I'm from the construction. That's what I learned. That's where I come from. So that's the way we build sometimes. It's a disaster. You know, I mean, 30% waste on a construction site. Sure, if you look at that. Chaotic process, inefficient executions, and most bad quality. And so that has to change, because we're building like 2,000 years ago. So we thought it has to be kind of systematic. We have to look at the quality, at the construction time, the resources, and the money. So that was the approach, and I said, we want a minimal consumption of resources when we go into cities. Energy efficient, economical, less expensive, adequate space, and short time for planning and design, and no noise and dust. This is very, very important if you're the neighbor. So, and why wood? Because wood has an ecological backpack of 0.3. Depends on how long the transportation is and if you use the material in the sawmill for heating or whatever. So, instead of having steel with a factor of 8 or concrete with 5, you have wood with a rucksack. That means to 1 kilo, you add 0.3 kilo for the rucksack. So from the resource issue, it's the best you can do. People sometimes ask me, what are you doing for business? I say, I'm working on carbon storage technology. And they say, this sounds like rocket science, you know, it's very interesting. It's a future market. Well, what exactly is that? I said, I build skyscrapers out of wood. So what? It's like, yeah, because 1 ton of cement produces 1 ton of CO2 in the atmosphere. And the atmosphere is the only waste dump where we cannot get back the stuff. It's a real problem. It's a waste dump. We just put it in there. And wood, for instance, is taking 960 grams, almost a ton, out of the atmosphere. It's the best way of carbon storage to plant trees. Sunlight and CO2 produces wood and oxygen. And we use the wood for building. That was our approach. That's why we ended up, we're looking all at the materials. We said, which materials should we take? I said, it was wood. It was not wood alone. You have to combine it, but it's mainly wood. So, but I mean, there's some wooden buildings in Austria too, 3-story, 4-story, so, but going up, you know, that's a hard issue because of all the building codes. Wood burns, that's right, but wood burns safely. So we put this slab into the biggest burning chamber in Europe, in Czech Republic, and we burned it for 120 minutes just to prove if it's still safe. And it worked out. You know, if you have a wood column, we use glulam columns, and it burns. You lose 2.5 centimeters an hour. But the rest is still there, 100%. If you have a steel building, you get 750 degrees, that's it. And no noise, nothing. It just collapses. That's why firemen prefer to go in wooden buildings. Because they know what is burning, how much is left. They hear if something cracks. No wooden building will ever collapse without noise before. So it's that simple. So it's calculated. But what we did is we went even further. We said no capsuling of the wood. You can see it, feel it, smell it. In this building, we want to see that's a wooden building, although it's probably a mid-rise building or a high-rise building, because it has just a different approach from the healthy side. So it's proven, they made a study in Austria that in wooden buildings, it's less stress, less heartbeats a minute. So in a company, when you build your office building with wood, for instance, you save a lot of money because people are less ill. So, but how about these poor forests? We're going to cut all the forests away and then we have a problem. That's what I hear sometimes. In Austria, we have a consumption of 300,000 bank meters and a growth annual of 434 bank meters. And although we are 50% exporting to UK and other countries. So, and there are countries like Canada, they're sitting on this treasure. The problem is that you cut the trees and export it. You should cut the tree and make high efficient building material, and you can do any building. And keep the money in your land and create green jobs, new jobs, and that's the big advantage you have here. So that's how the life cycle tower started as an idea, and we said it's not just a technical problem, it's a problem of working together. Different approach, different interests, different time when people come in. So the whole process has to be changed because the building physics, for instance, or the MEP planning is the big, big black box. There's one guy who knows exactly what has to go in the building, and nobody else knows. And that's sometimes when we recalculate stuff, that's really, you can save 30% of the stuff putting in sometimes, if you make a dynamic calculation and all that stuff. So taking a close look on that and not reinventing every time. So we say we want to 90% improved CO2 balance. That's quite logical because less concrete, more wood. It's just the opposite, plus to minus at the end. Reduced resource input and all the construction period. This building weighs 40% of a normal building, so you save money in the underground. And here you have the life cycle. One big issue is no supporting walls. We just have the core, the columns, and the slabs. So you can change this building anytime to any use you want to have. And that's sustainable too, if you don't have to tear down a building after 25 years because it's a different use. The next generation has other ideas. So we have to make sure that you can use this building 100, 150 years and always change what you want to do with it. And sometimes people ask me, how long can a wooden building last? And then I always bring the example of my parents' house. It's 1688 built. It's full wood, and they still live in it. So that's not the problem. It's always the problem where you use it and how you secure it. But more important is the question, which part of the building do you mean? Because I say the structural part has to work for 150 years. But other parts like the facade, where you have probably photovoltaic integrated, you can change in 40 years. The MEP panels, which is prefabricated too, you can exchange after 15 years with new technology. But you have to be able to exchange everything at the end of its lifetime and not tear down the whole building. This is a very important thing. So that's quite the technical system. We have a core, and we developed the core in wood with the only part with chips on board. We had to because of the stairs and the shafts for the elevator. And on this core, we have these slabs and the double columns. And here you see one facade type. You can have a total different facade. And it's a very, very simple model because you have the glulam beam core and then the composite slab and these columns. You just put one columns on the other column. So you don't have these knots, which are very, very hard to handle in wood. And here you see the principal concept. It's a very thin slab. It's 8 centimeters. The rest is glulam beams. And this slab, you have the acoustic issue solved and the fire stopper on every story. And it gives a total different feeling if you have wood and a little concrete in it, because it's from the temperature side, it has some advantages. So I just want to go, it's like Lego and Matador. So, you know, this part hurts a little bit because it looks so simple that after that everybody says nothing special. But that's the way it is, and that was the plan. We wanted to develop a total energy efficient, ecological, intelligent building with total simple parts. Because the idea is global regionalization. That means to spread the know-how, to spread the idea, and use local wood, the local material which is there, and the people who live there to build up these buildings and to produce the parts. So this is our approach. So we have these double columns. We have these steel joints just put in. Then the slabs comes, the ceiling you just put on, and the steel finger like goes through, as you see here. Then the other one comes, and then you close it with a small tube, and then you just grout it. That's the only thing which is wet. You will hear no vibrator, nothing, because that's annoying the neighbors. So you just have this grout, and you walk through, and that's it. And then you see, looking out the steel. Then the next columns are coming and go in exactly in these tubes of steel, because then you know exactly the accuracy of the building. And then it goes in. And then you just put the molding around and just a little bit grouting around. That's it. So that's the way we build. We build 1 story a day. We built this 8-story building, non-capsuled. Finished it last month and moved in last month. And first we had to do the core. And the core we had to do in concrete because the building code and the authorities, we don't want it to give them a too hard time, because we were so glad that they let us going up to 8 stories, not capsuled, that we say, okay, the core we make in concrete. We can make in advance. But then there are 8 stories. We build 1 story a day with 5 people. Here you see from the inside. That's how it looks when it's finished. Here you see the big advantage that between the glulam beams, you have all the building services you can put in between. You don't have this suspended ceilings, and you have you can use all the space. So on a couple of stories, you save 1 story, and you need less facade, because you put the, and these are prefabricated elements you can put in and put out. So nothing of the cables is in the concrete, because these are slabs too. So you can separate it. Again, you can separate it each. Here you have the heating, the cooling, the ventilation, the sprinkler, the smoke detector. We learned a lot with the building we erected just now, but the next building we're planning for ourselves, an office building, I said I want to kick everything out. I like the ceiling because you see the concrete and you see the wood. Why putting something in? And the guy said, we need a light. Okay, we can use like this, the standing lights. we need a cooling and heating. Why don't we put it in the slab? Just make it 2 centimeters thicker and put the tubes in it. So with the slab, you just connect it at the joints. You have heating and cooling done. So always think about what you don't need, not what you need. And Saint-Exupéry said, I was told today, perfect is a thing not when you cannot add something more. It's perfect when you cannot take something away. So, and this is one big message too. We always think more technology, more. It's not more. You know, that's the rebound. You know, it's always, we find something new to measure, as I told before, and we put more stuff in it. So for the facade, this is the a picture before we build it. This was from the architect. You can have a wide range of facades, and you can have it fully in glass, as I showed before. Sorry. And here you see the approach we have for the industrial manufacturing. We want to be specialists in providing the system, providing the testing, the calculation, and take care about production processes. For the second project we had to make a local producer fit to produce the slabs, for instance. So we come with a total different approach, like from the automotive industry. We just say we have to have this quality prefabricated. And we can check the quality before. When we put it together, it has to fit on a millimeter basis, because we built the passive house, the 8-story, and we closed it and it was tight. You cannot do this with a normal conventional building, everybody drilling stuff and doing different things. So construction process is first you have the core, you go up with the core. During the time you build the core, you can prefabricate all the rest of the parts. And yeah, that's one issue, the earthquake. Because of the weight saving, you have much less force going in the building. You have a high short time strength in the wood. And you have a flexible connections, and the wood itself is ductile. What we have here is that because it's prefab parts, in special places we have to connect the joints better. So we make this dynamic calculations. And here it's another life cycle, as I told you before. So when you start with the wood, you have the solar energy, the CO2, you produce the oxygen, you go to the sawmill, then the heating plant, what is left over, you go to the wood composite, make the product. This is a huge market for Canada. Just go into this CLT, glulam construction, because that will be a huge potential for market, for the economy, and for jobs here. If the authorities here can be convinced that buildings who work in other countries probably could work here too. So shortly to the project, this is the life cycle tower, and I mean it's not looking to Vancouver, it's not a real tower, but the small city we built it, it is a tower. It's 8 stories, and the outside is a recycling metal facade because we were not allowed to use wood in that case on the outside. So there could be a video. Sorry, I just tried this. The core we had to build before, and the building is not very big because it was way too expensive. It's a prototype, and I had to invest so much money in this building because I just wanted to build it and to show it, and that's why it's not a big size. Usually you could, around the core, it could be much more office space. So that's why it's just 1/4. Just you don't wonder in that. So this is the core, the shaft for the stairs and the elevator. And the rest just starts now. This is the first day. This is day 2. This is day 3. There were 5 people constructing this, and 800 people were visiting from Japan, Canada, US, you know, because everybody wants to see if that, how that could work. And so that was day number 7, and this was day number 9, and then it snowed. So we had just these 8 days in March. And it's already tight, you know. We have the windows in it. We don't have, as you see, the metal facade on it already, like just a cover, because that was from the danger from the quality. So, and after the first day or the second day, it always looked like this. So that's clean, you know. There's nothing. You just grout here. That's the only thing you do, and the rest is the way it is when you go to the next story. And here you see like the facade element. It already has the 2 glulam columns adjusted to the facade, attached to the facade. You could do it separately, and you could put the facade away later, but I mean this is just one lift. And here you see the facade going around the corner. You always have to do the corner like this, otherwise you get the joint on the corner. This is a slab. Here you see the glulam beams and the very thin slab. This is how it looks like right after the grouting here. And here you see how thin this slab is, the concrete slab. That's the minimum. We tested it. I mean, first we started with 12 centimeters. Then we saw it's way too much. And then we made less and less and less, because every kilo you put in, I mean, it's ridiculous. If you calculate a building and just stick with the building codes, you use way too much resources. Just calculate it. If you are in a special system, it's much easier to always recalculate it and optimize it. So that's a big issue. And then we had the problem that the concrete was the problem, not the wood, in the fire chamber. Then we realized that there's some humidity still in the concrete, and getting with the fire, with the heat, it cracks the concrete. That's why we said we put plastic Späne, small plastic parts in it. Yeah, plastic fiber in it, but not because of static, but in case of fire, it evaporates and makes space for the humidity, for the water. So that's how it worked. So here you see exactly the way it's put in. It's like, it's really easy. You don't need like skilled people. You just need to train them. Yeah. The limiting factor here that was interesting, was the scaffolding company. They said they had never this problem, that they are too slow with the outside the scaffold. And this is the second project. With the same system, we won, an architect won in an international contest. That's the architectural contest. That's the biggest wooden passive house office building in Europe. And it's 5 stories high and 120 meters long. So a lot of people say the skyscraper fell down, because I always wanted to have 100 meters. So probably we can do it in Vancouver someday. And here it's quite interesting that it was just the architect doing the design and doing the contest and just using our system, because he knew that's the only system he can go up to 5 stories without having problems with the building codes, because every part is proved. And that's a big issue, that today, with all the authorities, if you come with a wooden high-rise building or a mid-rise building, they will make a big thing out of it. So here you see it's quite big. It has 11,500 square meters floor space, and 6 stories. We say in Austria it's always first floor plus, so it's 6 stories high. And it's 1/3 is in the lake. And here the facade is in wood too, but a total different approach. I mean, that's the point. We have a structural system is like an operation system, and everybody can program software, like different facade on it, or making apps, you know, to compare it with Apple. So we have companies like Zumtobel or other really good companies. They say we want to have some products in your product, so in the same catalog. So because they see that there's a big chance here. Here's some pictures that's inside, a lot of wood too. And now we're working on the residential building. It's called Life Cycle Residential, LCR, because we believe that the US market, and probably Canada too, and the social housing companies in Austria and Germany will have a need for this. So that's why we develop now a type, we will be finished in March, to build residential buildings too. Because here we don't use the glulam beams with the slab. Here we have a CLT with slab, but everything is prefabricated. So it's cheaper. It is cheaper, and you have the same advantages. And here you see you need 2 cores. If you're along a building, we always, because we just have supporting columns with vertical loads, we always need cores. Stiffness. So here you have these 2, because you need the stairs anyway. So that's how we solve this. So that's it. Thank you very much. I'm ready for questions.
Thank you again. I was there this morning, and I'm still overwhelmed. I'm from Quebec, and we plan to do 8-story in CLT, but eventually we will do it maybe in this way. You told us that the slab was initially 12 centimeters. How thick it was at the end?
8.
8. It's a good.
Now we have 8. If we put in the tubes for heating and cooling, probably, just to put it away from the ceiling, then we would be 2 centimeters more.
Okay, thank you.
How do you deal with the different expansion and contraction coefficient of wood and concrete?
Well, there's not a big difference, as I know.
Wood and concrete? Oh, I don't know.
If the wood is, I mean, we use wood which is 12% dried. So depends on how the standard or the starting quality is of the wood. I mean, you have under the load, you have some reduction, but it's quite symmetric, so it's not a problem.
A question on your slabs, spans and loads.
Sorry?
Spans and loads.
How long
the span is 9.5 meters at the moment, and the load, I don't know exactly what that one, because we can change a little bit. You know, if we have different load expectance, or then we can work on it. It always stays the same system, but we optimize it then. Sorry. Yes, I mean, this system is suitable for office type and hotel, so this is not a problem. For the life cycle residential, we realized that we don't need that spans, so we can go to the CLT slab, and using supporting walls too with CLT. So we combine the best of each world or industry and material. You know, it's like assimilating material, not developing all new. Just put things together which fit, we think.
You mentioned that you like to see the wood exposed on the underside. With floor assemblies like this, how do you deal with sound transmission through the floor assembly?
The sound transmission from story to story? Yes. Well, we made a testing now, because now we have a building where we really can test on the original. And we realized that we don't have, we over-engineered a little bit. So we have much better numbers on that. So that's definitely not a problem. But I can deliver if you want more in detail. I can send you some information on that if you want. Oh, the window. The maximum opening is all glass, because you have the double columns you have, and you go in front with glass through. It's not a problem. The only thing you need is the columns and the slabs. The other things you can just design and do whatever you want. I mean, you can put balconies on it. That's what we tried. Just screw. I mean, the best way to connect material is like screwing, and wood, you just screw. I mean, it's like you can screw the balconies if you want on the outside. Yeah, I mean, it sounds cheap and I don't know, but it's, it has to be very, very simple.
What's the depth of that beam at the 30-foot span?
How
thick is it?
Can you help me? 10 inches, yeah, in inches.
Here you go.
And that's the space we have for the building service stuff,
Yeah, Hubert, thanks for the excellent presentation. I'm a fire consultant and building code consultant, so I'm interested in your fire testing, which seems quite rigorous and robust.
Yeah.
90-minute and 120-minute ratings. Were they tested as separate panels together, so tested with the joint configuration in place, or just as individual panels?
They were tested as individual panels.
Okay, so the joint condition was addressed as a sort of a separate fire protection filler, or like we call it fire stopping here?
We used the trick here because the slabs, as you've seen, has the concrete goes. How do I show it? Here you see it. On the facade side, or where the glulam beams is the concrete. The concrete is standing directly on the next column. So we cut the fire sections. And the other thing is that you should not put forces on parallel faces on the wood. So that's why. And that's why we were assuming that that's not the weak point, or at least from the technical side they did. And always the problem is the concrete. It's not the wood. And because
And the question I have relates to your ability, wanting to sort of balance between the single-family residence and the Burj Dubai. Is there sort of an optimal size building that you've conceived that balances population density with engineering concerns and environmental impacts?
6 to 8, maximum 10 stories. That will be the usual use of systems like this. But in some places in the heart of a city, it can make sense just to go 20 stories. Yeah, but usually the big market will be in resident buildings, will be 6, 8, or 10 stories. I'm sure, because then you can still achieve some social issues. I mean, it's not just technology.
What was the hourly rating required for this building as far as the fire goes? And what is the system rated to a maximum?
120 minutes. It's quite, it's different from country to country. The problem is, if you go to a new class of buildings, like from mid-size to high-rise, I mean, then we have a problem. We always have to prove that we compensate. We have to be better than conventional buildings. So if you have a 10-story building in conventional structures, and you would need already a sprinkler, you can not say, I have a sprinkler and I compensate that I have a combustible material. So that's the problem a little bit. And we think it's wrong that you always have to prove more, because the way we build has much more quality. So it's safer, I think, because in a normal building, you don't know what kind of material they leave on different places at the end, which is just covered, you know, and so, but that's it has to be a progress, and usually the codes today are experiences of the last decades, and sometimes the latest knowledge and know-how and testing is not spreading fast enough. So that's why it's so important that there's good interconnections between the codes and the experiences. And at the end, I just wanted to say, everybody was saying it's not possible to do this, you know, 100 meters. And we got some support from the ministry in Austria, and they say, but we just pay you some little subsidiary if at the end you prove that it can work. And we had to bring from the authority a letter that they would approve it, not from the country, from the city side, from the architectural side, but from the construction side. So that was, and that's when I always say, everybody says it's not possible, but then somebody came who didn't know that.
That's right. Well, with that and no more questions, I really want to thank Hubert Rhomberg for this excellent presentation.